Visible?
Okay, so I have with me a small weight. I mean, this is what you do in the use in the gym for lifting weights. So I have just borrowed one
How
from the
much?
school gym. Okay, it's a fairly heavy piece of iron,
5 kg.
2.5 pounds it says. Okay, so what I'm going to do to this is I'm going to tie some strings onto this. Okay, OV is here. Okay, so there is a weight. I have suspended it on this. You can see that it's freely suspended, right? And I have tied
Yeah.
one string to the top. You can see the string clearly. And then there are two strings that are tied to the bottom.
Okay.
Okay. Now,
Yeah.
these two strings are almost of equal length. Yes, you are able to see that?
Yeah, sir.
Yeah, sir.
Yeah.
Okay. Now, what I'm going to do is I'm going to pull on the lower strings. Okay. So the lower strings I will pull. Now, what you have to do is you have to predict and tell me when I pull the lower string whether the upper string will break or the lower string will break. Obviously, if the upper string breaks, then the whole object will fall to the ground. And if the lower string breaks, then
Only
I
the
can
string
show you, I
falls.
can bring
Nothing
the string and
happens.
show it to you. All right.
Yeah.
So please make your predictions. Send your answer by chat. Upper string or lower string, which will break?
Privately or public?
How are you pulling it?
Guys, send private chats.
I'm just pulling it.
It depends on.
Are you pulling it downwards or sideways? Sir.
Send it privately.
Sir.
Yeah. So some people have read the
Sir.
textbook, and some are saying okay upper string, one or two are saying lower string, and others are saying depends on how you pull it. Okay. So I'm going to do it now. So what I'm doing is I'm taking one of the lower strings, okay, and I'm going to pull it. So it's 1, 2, 3. So what happened?
Lower
Lower
string.
string. The lower string.
Lower string broke. Okay. Now you could ask the question, why did the lower string break? So what's your answer to that?
Me, sir, can I answer?
Sorry?
Sir, can I answer?
Yeah, please.
The lower string broke because the weight of that, what do you call it, tumble or something, whatever it is, uh, its weight was heavy than the string, or because if you pull it down, the string should have that much weight and force to pull it down. So the string had less weight than that, what thing is that? Uh,
Okay.
then the
The
thing over
object.
there, and
Basically,
then
what has
it just fell.
the string broke because it could not bear the force that was applied on it. Correct?
Wait.
Yeah,
And
sir.
mind you, this string
Yeah.
Yeah.
is quite strong. Okay, I'm pulling it quite hard. I'm getting marks on my skin, but it's not breaking. I deliberately chose this strong string. It's a pretty strong string. Okay. Uh, can I have one more answer? Shiv, I think you wanted to say something.
No, sir. Same. Same. Have an answer.
So can you
Same
answer
thing
it
as
from an
Arman.
inertia point of view?
Yeah. Yeah. So, yeah. So
Yeah.
when you pull it hard,
Yeah.
something has to break, right? So when you're pulling it really hard,
Yeah.
then the inertia of the weight
Yeah.
prevents it from moving.
Yeah.
So it stays there.
Yeah. Exactly.
But then, so the lower string breaks.
And therefore the lower string breaks. So that means
Yeah.
that there isn't enough force that is being applied on the weight to make it move down. The weight is resisting because of its inertia, it doesn't want to move. So because of that, what happens is when I pull hard enough, there is something called the tension that builds up in the string. Okay, when you tighten a guitar string, you give it some tension, and because of that tension, it plays a certain tune. So there is a certain amount of maximum force that this string can bear, and beyond that force, if you apply it, then it breaks. Okay, otherwise it will not break. And obviously, the tension became high enough in the lower string for it to break, which means that the string, therefore, has a maximum amount of tension that it can bear before it breaks. So no matter how I pull the string, the lower string should break, correct?
Yeah.
I would like to demonstrate something different. So when I pull the lower string, not the way I did it the first time, but in a different way. Okay, so now watch carefully. Now what happened? You can see
Hold
obviously
it for longer.
part of the string is dangling over here and other part is there stuck to the weight. I don't know if you can see it against my shirt. You can see it, right? It's broken.
It's visible.
Yeah.
The other half is over here.
Dangling.
So how did that happen? Why does it break in the lower string when I pull it hard, when I give it a jerk? Whereas when I pull it slowly, the upper string breaks. What is the reason for that? Yes, Shiv.
So, like, what you did was in this one, like, you
1 second, 1 second.
grip.
Sorry, there was a tractor moving past, so there was a lot of noise. I just muted myself. Go ahead.
Yeah. So like in this demonstration, in the second one, like you grip this string like pretty well, okay, and you gave it a jerk, so the like power of that
Hey,
dumbbell thing.
you're calling me a jerk?
No, you
No, you
gave
jerked
it.
it.
What is
Yeah,
You
gave it.
jerked it.
Kya hai? Okay, sorry, go ahead. That was just supposed to be a joke.
Yeah. Okay. So like you pulled it like very hard. So the thing which is like the object which was dangling, like it's like energy took the string away and yeah.
Yeah, so it's actually something that's not very easy to explain. I have shown this demonstration many times. Yeah, so like I was saying, the situation is kind of like this. Okay, now what happens is when I pull the lower string with a force, except that I give it a jerk. Okay, then what we saw was that when I pull this, there is a tension in the string that gets built up. Now, because the mass has an inertia, it does not want to move. So what ends up happening is that the object remains exactly where it was, okay, and the string snaps, right? This is understandable. But when instead of giving a hard, sharp pull downwards, if I build a force which is slow, so if I pull in a slow way, then something different happens. The lower string is now intact, whereas the upper string breaks. So that means naturally the tension in the string built up over there. So it's a question of, in either of the two cases, how come the tension exceeds the maximum tensile strength? We call the tensile strength of the string.
So you did it fast there, right? Where the niche wala string broke.
Okay, of string. And in the case when you put a sharp pull, the tensile strength gets exceeded for the lower string, but when you pull slowly, the tensile strength gets exceeded for the upper string. And that's the reason why the upper string breaks. The lower string is easy to explain. The upper string is not so easy to explain. I haven't yet heard a convincing enough argument of why the upper string actually snaps. Anything anybody wants to add now to this?
Sir,
Yeah.
like when you're doing it slowly, it's like the you're also not like it's not the constant not constantly the same amount of
It's
force you're
cracking.
giving it, right? So you're increasing the force.
No, it doesn't increase the force, but basically, how do you say it increases
You
the?
increasing the force. Are you increasing the force from your hand? Like
Yeah, yeah.
slowly, like are you
In the
right?
second case,
So it's like
in this case.
yeah. So instead of it, yeah. So like it gives the time like to I don't know somehow like travel up.
Yeah, so this question of time is the one that is a problematic one to consider. Over here, you don't give enough time for this mass to respond. Whereas over here, somehow there is sufficient time for the mass to respond and reach the upper string, so to say. It's actually not reaching anywhere. When you pull, the tension gets distributed in all the strings at the same time with the same amount of intensity, the strength. But in this case, the pull downwards plus the force with which this resists movement increases the tension over here. But in this case, what happens is the mass actually starts to go down. So if you actually perform the experiments, and please do it carefully, don't hurt yourself, don't use a very heavy weight in this place. But if you do it slowly, you will see that the mass actually moves down a little bit before it snaps. So then you can observe that
Yeah.
why is it that the weight of this object, that is the force which is with which the gravity is pulling it down, plus the force that you are applying, that somehow translates to an increased tension in the upper string. So because of that, the upper string breaks. Okay, so if there are any further observations, please contribute. Meanwhile, I'm going to set up the next one. Okay.
It will be
Okay,
successful.
so now I'm going to show another demonstration, again involving inertia, and basically it's the tablecloth experiment. So I have a box of tuning forks, and so it's quite heavy, it's metal tuning forks. I place it in the center, and then I have this, I'm just using my dhoti as a tablecloth, and what I'm supposed to do is pull it out quickly enough so the inertia does not have time to respond. It resists changes in its state of motion, so it will remain wherever it is because the friction between this and the cloth is insufficient to cause it to move. So let me make sure the cloth is all right, and then I do it 3, 2, 1. Okay, so you see the cloth went out from under, but the object more or less remained in the same place. There's a little bit of movement, but that's unavoidable. Now, having said that, it's, I mean, what's the great risk in doing it with this object? Even if it falls, there's nothing going to happen. There's just going to be a lot of clatter, and then it's all right. I can put everything back in place. The real thing would be
Sir,
take a chance. Yes, any questions?
yeah, so if you keep the tuning fork ka dabba there,
Yeah.
and it's the same thing as holding a finger or holding it in place and then pulling the cloth out, because even if you don't physically hold something, there's some force holding it together, preventing it from moving, right? Or is the force,
Well, it's not.
so is the force acting upon it, or is the force not acting upon it, and that's the reason it's not moving?
Yeah, you have to look at the first law. The first law says that an object will continue in its state of motion or rest on a straight line unless an external unbalanced force acts on it. So there may be forces acting on it, but it does not move much. I have to say, it moved a little bit. So it does not move much because the forces are not sufficient to cause it to move. So why does an object remain in the same place is because there aren't any external forces acting on it. Okay, but when I pull the cloth, obviously I am causing some external forces to act on it. It is just that the external forces are insufficient to make the inertia respond. Okay, but anyway, tuning fork box, not a big deal. It's time to raise the stakes, and I raise the stakes by placing 2 glass objects on it. Okay, this is real glass objects, so it's not fake plastic objects that will that is not much risk in doing. So now I have to say, object stolen from my kitchen, I have to replace it back by 4 o'clock, which means that I have to replace it back complete, unmolested, unbroken. Otherwise, I'm going to be in a little bit of trouble. I have to be eating out of stainless steel ware, which I don't like. Now,
That you can say a dog ate it.
so now I have to do it with these 2 objects, and boy, am I nervous. I better get this right. So I just need complete silence. Nobody says anything. If you make some noise, I may pull it in some other weird way, and then the things will go falling and toppling all over. It might break. So please, complete silence. 3, 2, oh God, no, I can't do this. Let me get a drink of water first.
Sir, this isn't a reality show. Please.
So are you going to place
have a
it near
script.
the edge again?
Thirsty, man. Okay, I'm taking a great risk, all for the sake of science. Okay, so that
I already did this.
All right, so I'm ready now. I hope, I think. I just keep this a little closer to the edge, maybe pull it a little closer, and say 3, 2, 1. Ha!
Boom.
Oh.
Boy, yaar.
Sir,
Wow.
BTW, you were saying you were taking such a great risk. Galileo went to jail. I mean, this is of course worse, but yeah, even he took a great risk.
So I have to say, physics works. I'll meet you people on Monday when we have the next class.
Bye,
Okay.
sir.
Bye, sir. Bye, guys.
Bye.
Bye,
Bye.